Hi, myself G. Lavanya, working as Assistant Professor in the Department of Biomedical Engineering, Sri Ramakrishna Engineering College, Coimbatore. In this video, we are going to discuss about the topic defibrillator. In this presentation, which covers the principle and need of the defibrillator, how the energy is stored and discharged in the defibrillators and the waveforms used and the precautions and risks associated with the defibrillator. Let us see the presentation. So, the main objective of this defibrillator, define the definition of the defibrillator, describe need and history of the defibrillation, describe the principle and mechanism of defibrillation, the electrodes used in the defibrillator and the different types of defibrillator, DC defibrillator and automatic external defibrillator, and identifying the precautions and risk associated with the defibrillator. So, the defibrillator is a device, electronic device that sends an electrical shock towards the heart. So, whenever the person's heart stops due to cardiac arrest, we have provided the defibrillation. So, it is mainly used for commonly treating the cardiac dysrhythmias such as ventricular fibrillation and ventricular tachycardias. Ventricular fibrillation is nothing but rapid uncoordinated querying of ventricles, and ventricular tachycardia is a fast beating of ventricles. So, due to that, the blood flow should be reduced. So, this is the device which is used for restore the normal heart rhythm. So, the need of the defibrillator. So, ventricular fibrillation is a serious cardiac emergency which results the uncoordinated contraction of the heart muscles. So, due to ventricular fibrillation, there is an irregular heart rhythm. So, the picture which defines the normal and abnormal heart rhythm. So, the first picture which defines the ventricular fibrillation. So, we can see that there is a difference in the waveform, and this is the normal heartbeat. We have PQRST waveform. So, defibrillator. So, with the ventricular fibrillation which can be converted into more efficient rhythm with the help of defibrillator. So, we can provide high energy shock towards the heart. With the help of that, we can convert into a normal efficient rhythm. So, this sudden surge across the heart which can causes all the muscle fibers to contract simultaneously. So, possibly the fibers may then respond to normal physiological phasing, making pulses. So, the instrument we used to device they called as defibrillator. So, the main purpose is to correct the life-threatening fibrillation of the heart which results in cardiac arrest. So, it should be performed immediately after identifying the patient is experiencing a cardiac emergency. During that time, the patient should not have no pulses and it is unresponsive. So, the history, it was invented in the year of 1899 by Prevost and Battelli by two Italian physicists. So, they discovered the electrical shock for the ventricular fibrillation that was done for dogs. So, the first case of human life saved by defibrillation was reported by Beck in 1947. So, a 14-year-old boy suffered from prolonged period of ventricular fibrillation during an operation for pectoris excavatum. So, the chest valve is already open, the fibrillation heart was fully visible. So, during that time the pad is applied directly towards the heart. After applying the 4 shocks of 110 voltage, the boy made a full recovery. The principle of defibrillation. So, here main principle used here in the defibrillator, use of storage capacitors. So, the energy storage capacitor is required. So, we have to store the energy. So, for that we have using this capacitor. So, energy storage capacitively we can store at from the AC line. So, energy stored in the capacitor we can deliver at the rapid rate towards the chest of the patient. So, in this circuit diagram we have a capacitor. With the help of that we can discharge the energy towards the patient through own resistance. So, the resistance which the patient represent a purely ohmic resistance. It is around 50 to 100 ohm with the electrode size of 80 centimeter square. So, the waveform we used here is Lawn waveform. So, it should be like this. So, this waveform is very effective in delivering the shock towards the heart to restore the heart rhythm. The defibrillator strength and duration curve. So, the operator have to select the energy. We have a energy from 50 to 360. So, depending upon the patient condition, we have to select the energy such as intrinsic characteristics of the patient, patient diseases, duration of arrhythmia, patient age and types of arrhythmia. So, based on this condition, we have to select the energy from 50 to 360. So, the mechanism. So, we have to stop the fibrillation with the help of defibrillator. So, fibrillation causes the heart to stop pumping the blood which leads to brain damage. So, defibrillator which delivers the electrical shock towards the heart which enable the heart natural pacemaker to regain control and establish a normal heart rhythm. So the power of defibrillator. So higher voltage which we apply through external defibrillation. So with the help of that we can deliver a shock towards the heart. So usually the corrective shock is 750 to 800 volt is applied within 10th of second. The same voltage we can apply in AA batteries such as 500 to 533. Electrodes. Next we have to see the electrodes. So there are different types of electrodes are used. First one is spoon shape, second one is paddle type electrodes, third one is pad type electrodes. So spoon shaped electrodes applied directly towards the heart. Paddle type electrode applied against the chest wall. Pad type electrodes applied directly on the chest wall. This is the spoon type electrode and paddle type electrodes. So this is a pad type electrodes. This electrode should be helpful to deliver a shock towards the heart. The placement of electrode is very important. So we have to place the electrode in anterior region and apex region. So based on that we will get a two waveforms. One is monophasic waveform and biphasic waveform. So usually the energy delivered in one direction towards the patient heart we called as monophasic waveform. The energy delivered in both direction towards the heart is called as biphasic waveform. So usually this is the output. So energy we can deliver in one direction. This monophasic waveform, the waveform should be like this, and delivered in both direction the waveform look like this. So we have two waveforms in this class. So usually preferred is biphasic waveform compared to monophasic waveform to defibrillate. Because a monophasic type we have high energy shock should be delivered up to 360 to 400 joules. So due to which increased cardiac injury it causes burns in the chest around the shock pads sides. So biphasic waveform we can give two sequential low energy shocks of 120 to 200 joules with each shock moving in opposite polarity between the pads. So that's why biphasic waveform is preferred. So we can provide two different electrodes. One should be anterior and apex region. With the help of that we will get biphasic waveform. So two different types of defibrillators. One is internal defibrillators and external defibrillators. Suppose if the heart is not at all working, during the time we can go with internal defibrillators. So electrodes applied directly towards the heart, example pacemaker. External pacemakers we can apply temporarily. So electrodes placed directly on the heart. So a main example for this external defibrillator is automatic external defibrillator. So this is an example. So here it is a pacemaker and this is the device for defibrillator. So external defibrillator. For each minute in a defibrillation after the onset of ventricular fibrillation, the survival rate decreases by 10%. So earlier defibrillation is critical for saving lives in cardiac arrest cases. So defibrillators are portable, battery operated and compact devices. So the energy we can store in large capacitors. With the help of that we can deliver necessary energy towards the patient like a high energy shock. So total energy we can store in the capacitor, we can calculate it by this formula W, which is equal to 1 by 2 CV square. So DC defibrillator. So DC defibrillator are commonly used because they provide minimal side effects. With the help of that we can restore the normal heartbeat efficiently. So ventricular fibrillation can be stopped by delivering a high energy shock with the help of discharging capacitors directly towards the heart or chest. In modern transthoracic defibrillators, energy can be stored in the capacitor which is charged slowly within seconds using either an AC power setup transformer with rectifier or battery with DC to DC converter. So when needed, this energy is rapidly delivered to the chest to restore the patient proper heart rhythm. So in this arrangement circuit diagram, we have to discharge the energy that is stored in the capacitor through the patient body, which act as a resistance. So in this setup behave like a classic resistors and capacitor circuit. So in this RC circuit, when the capacitor discharges, the current decreases exponentially over the time. This means the current start at a peak value and gradually falls off following an exponential curve. So the pulse shape, if the duration of the shock that is smaller, much smaller than the circuit time constant, which is tau, which is equal to R into C, the current pulse look like a rectangular waveform. So a sudden rise and almost a constant current for duration of shock before it stops abruptly. If shock duration is longer, that is closer to the time constant tau R into C, the pulse become a trapezoidal. It starts from high and then it gradually decreases and creating a shape that slow down towards instead of staying flat. So DC defibrillator, this is the circuit diagram for DC defibrillator. In a defibrillator, there is a auto transformer, which means a high voltage transformer whose output can be rectified with rectifier, and it is used to charge a capacitor through a high voltage switch. So there is a capacitor, 16 microfarad capacitors. So when the shock is needed, the switch changes its position and the capacitor discharges rapidly through the patient heart via electrodes. So initially a high voltage of about 4000 voltage is applied, but short pulses and high current can affect the heart ability to contract. So to protect the heart, the current limiting inductor is added. So that's why we have added the inductor in this circuit. So to protect the heart, the current limiting inductor is added in this series, which slow down the discharge and shape the pulses in a way that is safer for the heart. Although the inductors waste some energy due to its resistance, it creates a favorable pulse shape. The shape of the defibrillation pulse always depends upon the value of capacitor and inductor, but the overall pulse pattern stays mostly the same. Only the strength of the current changes with the patient resistance. And second one is automatic external defibrillators. Instead of providing with the help of physician, it automatically delivers energy towards the heart. The device we called as automatic external defibrillator, which is called as smart or advisory defibrillators. So in this device, it can analyze the ECG accurately and make a reliable shock decision like pretrained paramedics. So they can deliver a shock automatically or recommended whenever needed. So in this device, they use a self-adhesive electrode, not paddle, for safer and more accurate defibrillation. These electrodes reduce noise and improve the ECG quality, which allowing faster and better shock decisions. So this is a device for automatic external defibrillator. So the precautions, the paddles used in this procedure should not be placed on the woman's breast and also it should not be placed over an internal pacemaker patients. Before the paddle is used, the gel must be applied to the patient's skin, which is very helpful for connectivity. And the risk associated with the defibrillator, so skin burns which can causes due to the defibrillator paddles. It is the most common complication usually occur in the defibrillation. And also other risk which includes injury to the heart muscle, abnormal heart rhythm and blood clots. So as of now, we discussed about the defibrillator and the different types of defibrillator used. So proper handling and technical knowledge is essential for utilizing this device. Thank you.